There are eyes on this planet that are basically living fossils. Eyes that are technically an optical illusion and not a real color at all. And at least one eye color so rare, some eye doctors go their entire career without ever seeing it in person. We're talking about eye color. All of it. By the end of this video, you're going to understand exactly why your eyes are the color they are. Why some colors are common enough to be boring and others are rare enough to stop people in their tracks. And why a couple of these colors are, scientifically speaking, kind of a lie. It all comes down to one single pigment and a bit of physics. Let's get into it. Okay, foundation first, because everything in this video hangs on this one idea. There is only one pigment involved in human eye color, just one. It's called melanin, and it's the exact same pigment responsible for the color of your skin and your hair. There is no blue pigment, there is no green pigment, there is no grey pigment. There is only melanin, which is brown, and then a whole lot of clever tricks with light. As many as 16 different genes control how much melanin ends up in the front layer of your iris. That's why eye color isn't a simple one-gene coin flip like you might have been taught in school. It's a dial being turned by more than a dozen genes at once, which is why there's such a smooth range of shades between people. Here's the rule that governs the whole spectrum. More melanin means a darker eye. Less melanin means a lighter eye. Simple so far. But here's the twist that makes eye color genuinely fascinating. The lighter colors aren't just less brown. Once the melanin level drops low enough, something else takes over. Light starts scattering off the microscopic structure of the iris itself, and shorter blue wavelengths scatter back at you more than the others. It's the exact same reason the sky looks blue, even though the air isn't painted blue. So some of these eye colors aren't pigment colors at all. They're a lighting trick that your own eye is playing on you every single day. Hold on to that idea. It's going to come back and explain half the colors on this list. All right, let's count them down, from the most common eye color on Earth to the rarest. Starting at number 1 for commonness, brown. Somewhere between 70 and 80% of every human being on the planet has brown eyes. That makes it, by an enormous margin, the most common eye color in the world. Brown eyes have the highest concentration of melanin, which is exactly why they're brown. All that pigment absorbs most of the light that enters the eye. But here's the part most people don't know. Brown wasn't just the most common eye color. For most of human history, it was the only one. As far as scientists can tell, every single human being had brown eyes up until somewhere around 10,000 years ago. Every other color you're about to see traces back to a genetic mutation that started dialing melanin production down. In other words, if you have any eye color other than brown, you are carrying the result of a relatively recent genetic plot twist. And as a bonus, all that extra melanin gives brown-eyed people a little more natural protection against UV light. Next up, the second most common, blue, sitting at roughly 8 to 10% of people globally. But that global number hides just how wildly uneven blue is across the map. In some northern European countries, blue is the majority. In Iceland, for example, blue is actually the most common eye color, flipping the entire global ranking on its head. And blue is where our light trick makes its grand entrance. Because I need you to really sit with this. There is no blue pigment in a blue eye, none whatsoever. A blue iris has very little melanin, and that low melanin structure scatters light in a way that sends blue wavelengths back to the viewer. It is structural color, the same physics that colors the sky. If you took a blue-eyed person and could somehow switch off the light scattering, their eyes wouldn't look blue at all. There's genuinely nothing blue in there to find. Every blue-eyed person you've ever met has, in a sense, been wearing an optical illusion. Now let's move into the middle of the spectrum, hazel, which shows up in around 5% of people. Hazel is the tricky one. It's not a single flat color, but a blend, usually green and brown mixed together, often with flecks of gold or amber scattered through it. Hazel eyes have this famous reputation for seeming to change color depending on the lighting, or the color of the shirt someone's wearing, or whether they're indoors or out in the sun. And that reputation is actually earned. Because hazel sits right in the middle of the melanin scale, it's balanced on a knife's edge between pigment and light scattering. So when the lighting around it shifts, the balance tips, and the eye genuinely reads as a different shade. It's not your imagination. Their eyes really are shifting. Now we cross the line into the genuinely rare colors, and we start with the famous one, green. Only about 2% of the entire world's population has naturally green eyes. 2%. That makes green one of the rarest eye colors on Earth, and it's most concentrated among people of European descent. Green is the perfect midpoint of everything we've talked about, a small amount of melanin combined with that same blue light scattering effect. The little bit of pigment plus the scattered blue light mixed together, and the result reads as green. If you have green eyes, look around the room. Statistically, you might be the only one. Getting rarer still, we reach amber. And amber gets confused with hazel constantly, but they are not the same thing. Where hazel is a shifting blend of multiple colors, amber is a solid, uniform, golden color, the same from edge to edge. It's caused by a different distribution of pigment that gives the iris that warm, coppery, almost glowing gold tone. Now, how rare is amber exactly? Honestly, the estimates are all over the place, ranging from around 2% up to 5%, depending on which source you trust, because there just isn't one big global study that nails it down. So take any specific number with a grain of salt. But here's the fun part. That same golden pigment tone is what gives wolves, owls, and house cats their striking amber eyes. So if you've got amber eyes, you're in good company with some pretty cool animals. And now we arrive at the rarest color that most people will ever actually encounter in real life. Grey. True grey eyes are astonishingly uncommon, with estimates putting them at around 1% of the global population, or even less. At a glance, you might think grey is just a washed-out version of blue, but it's actually its own distinct thing. Grey eyes have very little melanin, just like blue, but the structure of the iris is different. It scatters light in a way that produces that silvery, almost smoky, storm cloud appearance instead of a clear blue. Some grey eyes even seem to shift toward blue or green depending on lighting, which just adds to how mysterious they look. If you ever meet someone with truly grey eyes, take a good look, because you may not see another pair for a long time. Okay, now for a quick bonus round, because this next one isn't technically a color, it's a whole category of its own. Heterochromia. Heterochromia is the condition of having two differently colored eyes, one blue and one brown, for instance. It happens when melanin gets distributed unevenly between a person's two eyes during development. It affects well under 1% of people. And here's the important part. In the vast majority of cases, it is completely harmless. It's not a disease. It's not a disorder. It's just a striking natural variation. Some of the most memorable faces you've ever seen probably had a touch of it. There's also a version where a single eye has two colors in it, split like a pie, which is arguably even more mesmerizing. And finally, we reach the tier that, biologically speaking, isn't really supposed to exist at all, red and violet. Here's the truth. Humans do not naturally produce red or violet eye pigment. Full stop. That pigment does not exist in us. So when you do see eyes that look red or violet, what's actually happening is this. It typically occurs in people with albinism, where the body produces so little melanin that the iris is almost completely without pigment. With nothing there to provide color, light passes through and reflects off the blood vessels at the back of the eye. And depending on the lighting, that reflection can read as red or as a soft violet. So this isn't a color being created at all. It's the absence of any color, letting something underneath show through. It's arguably the most extreme version of the light trick we've been talking about this whole video. So let's zoom out and put it all together. From most common to rarest, brown, then blue, then hazel, then green, then amber, then grey, plus heterochromia and the red-violet effect sitting completely outside the normal scale. Every single one of those colors, all of them, comes down to just two things. How much melanin is sitting in your iris, and how light bounces around inside it. That's it. one pigment, and a bit of physics, producing this entire breathtaking range across 8 billion people, with no two pairs of eyes exactly alike. So now I have to know. Drop your eye color down in the comments, and let's see how the numbers actually shake out in this community versus the worldwide stats. I'm genuinely curious whether the rare ones are overrepresented here. If you learned something today, hit subscribe. It really does help the channel more than you'd think. And I'll see you in the next one.